Good evening, GCC. We're going to be starting, this is the Math 150 class. We're going to look at Chapter 6, which is all about exponential and logarithmic functions. Exponential and logarithmic functions. There's a lot of applications with exponential and logarithmic functions. This is a long chapter, pretty important chapter in the big scheme of things as we get away from the linear functions, nice and well behaved, getting away from quadratic functions and looking at exponential functions. It's going to be a little bit all over the place here as we talk about these things. We're going to build up to what is an exponential, what is a logarithmic, and the very important relationship between exponential and logarithmics. We're going to start in 6.1. We're going to talk about something called composite functions. And I want you to think about a composite function as a way of joining two other functions. So with composite functions, if we have two other functions, for example, supposedly we have an f of x and a g of x. We've already seen that we can combine these functions in lots of different ways. We can add the functions f of x plus g of x. And when we do, we can treat this as a new notation, f plus g of x. We can subtract the functions, take the difference, f of x minus g of x, which would be another way of noting that, f minus g of x. And notice, f plus g of x would be the same thing as g plus f of x. They really would be the same function. F of x minus g of x would not be the same if I did it the other way around, g minus f of x. I can also multiply f of x times g of x. Remember the little multiplying dot right there? And I could denote that as f times g of x. And I could divide, take the quotient, f of x over g of x. And the new notation for this would be f over g of x. And does order matter for multiplying? Is f times g of x the same thing as g times f of x? Yes. Dividing, is it the same? F over g of x or g over f of x quotient would be different. So for the sum and product, it really doesn't matter. You're going to end up with the same final function, but difference and quotient does matter. Now these are ones that we've talked about and seen before, but here comes the new one, composite functions. So a new idea here, composite. What is a composite of two functions? Well, again, given some f of x and some g of x, I can have the composite function f of g of x. The little open circle here. Don't confuse this with the product. It's not multiplying. The little open circle represents some sort of composition. This is actually the new notation, f of g of x. The old notation, another way of thinking about this, this is really the same thing as f of g of x. And here comes a crazy sentence. To find the composition, we put g of x in for x in f of x. Let me say that again. We put g of x in for x in f of x. All right, so that's the concept here. Let's actually take a look at an example. Let's do an example here. Suppose I have f of x equals to 2x squared minus 3, and another function, g of x, equal to 4x. And I want to find f of g of x. And this is an open circle here. Oh gosh, I think I made it worse. That should be an open circle. Try to differentiate between an open circle and a closed circle. Open circle is composition, this new thing. Closed circle would be multiplying, so that should be an open circle there. I don't like that. Let me redraw that. F of g of x. There we go. That's a little bit better. So again, the idea is I'm going to take g of x and plug it into x in f of x. So I'm going to take what g of x is, this part right here, and I'm going to plug it in for x in f of x. I'm going to plug it into there. Substitute it in. All right. So f of x equals 2x cubed minus 3. F of g of x equals 2 times x. But what is x? G of x. What is g of x? 4x. So I'm taking g of x and I'm substituting it in for x and f of x. So here's f of x. F of g of x. Take the g of x and substitute it in there. And of course I can simplify this. 2 times 4 times 4 is 16x squared minus 3, which is 32x squared minus 3. That is f of g of x. Let's do it the other way around and see what happens. Now let's find g of f of x. So now what I'm really going to do is I'm going to take g of x and I'm going to plug f of x, substitute f of x in. All right, well, g of x I know is the 4x. So g of f of x is 4 times x, but instead of x, I'm putting f of x in there, which is the 2x squared minus 3. Let's simplify this. So substituting f of x into g of x. 4 times 2, 8x squared. 4 times 3, minus 12. And I want you to see that f of g of x and g of f of x are two completely different things. We can also evaluate them. We can plug a specific number in there and find the value. For example, let's do another one here. Let's find g of negative 1. So this is a composition of functions. This looks a little bit weird. What is this telling me? It's telling me I have to take g of x and whatever that is, plug it in for x in g of x, and then evaluate it at negative 1. All right, so let's see. G of x is equal to 4x. G of x is equal 4 times x, but instead of x, I'm going to plug g of x in there. I'm going to plug 4x in there. So g of x is 16x. But I'm not done. I still want to evaluate it at negative 1. So this is my g of x. G of negative 1, 16 times negative 1, negative 16. All right. We also need to talk about finding the domain of these compositions. So let's focus on the domain now. Suppose that I've got a function f of x equals x squared plus 3x minus 1. That's a nice, well-behaved polynomial function. And what's its domain? The domain of that function is all real numbers. There's no restrictions there at all. Another function, g of x, another nice, well-behaved polynomial function, 2x plus 3. And again, the domain would be all real numbers there. There's no restrictions there at all. The domain would be all real numbers. All right, so if I want to find f of g of x, I'm going to start with f of x, and I'm going to take g of x and plug it in for x and f of x. I'm going to take this and plug it in everywhere I see an x over here. So f of x equals x squared plus 3x minus 1. F of g of x equals x squared, 2x plus 3 squared, plus 3 times x, which is 2x plus 3 minus 1. All right, let's clean this up here. If I FOIL this out, I'm going to get 4x squared. 2 times 3 is 6x, and another 6x, and then another 6x, and then a 9. Distribute the 3. 2 times 3 is 6x plus 9 minus 1. Simplify, combine like terms, write it in descending order. 9 and 9, 18 minus 1 plus 17. Now, since the domain of f and g are all real numbers, then the domain of my new function would be all real numbers as well. Now, is that always going to be the case? No. These are nice, well-behaved polynomials. There's no domain restrictions here, no domain restrictions here. But what if one of our original functions had some sort of domain restriction on it? What then? Well, let's take a look at that. Let's see what happens. So now let's consider the function f of x equals 1 over x plus 2. This one's going to be interesting. It's going to have some domain restrictions there. G of x equals 4 over x minus 1. Again, another very interesting one. That's going to have some domain restrictions. Think back to when we did domain and range. Now, range I don't really care about so much right now, but I really want to focus on the domain. Now, if I look at each one of these individually, the domain here is, it has a restriction. X cannot equal negative 2. It can be anything you want except for negative 2. So the domain is the set of all x's except x cannot equal negative 2. What's the domain here? Well, what are the restrictions? X cannot equal 1. So it's the set of all x's except x cannot equal 1. Okay, so there's my domains. Let's find f of g of x. Now, there's going to be two parts to this problem. First is going to be finding the actual composition, and then second, what is the domain of the new function? Well, f of g of x, I'm going to take g of x and plug it in for x in f of x. All right, here we go. So I'm going to start with just plain old f of x. Here's f of x, 1 over x plus 2. Here's f of g of x. What I have to do is I have to take this and plug it in for x. 1 over 4 over x minus 1 plus 2. Substituting that in for my g of x. And I'm going to need to simplify this here. And I can simplify this, get a common denominator, rewrite this, and there's my composition. Again, focus on substituting this in there for that and simplifying this. But really what I want to do is, I'm just going to leave it like that, which is bad form. But I really want to focus on the domain. Find the new domain of f of g of x. And I might look here and think, well, it seems like 1 is the only value I'm not allowed to have here. But really, this tells me I can't have negative 2. So this, the original function for g of x, is not allowed to equal negative 2. So that's where the domain comes in. What I really need to solve is, when is g of x equal to negative 2? For what values is this original function going to be negative 2? Because I'm not going to be allowed to have that. That's going to be a domain restriction there. All right, so let's see. If I cross multiply here, I get 4 equals negative 2 times x minus 1. 4 equals negative 2x plus 2, subtract 2, divide by negative 2. I get x equals negative 1. So I also have to exclude negative 1 from the domain. So the domain, here it comes, the domain of f of g of x is going to be all the x's except for such that x cannot equal negative 1 And of course, it can't equal positive 1 either. The original function, g of x, it couldn't equal 1. So this is not going to be defined. The composition is not going to be defined when x is negative 1 or positive 1. All right. So that's composition. And a quick note about the domains of compositions. Gosh, I wish this lesson was in person so we could ask questions. The lessons tend to go by a lot faster when there's nobody asking questions, but it can be very frustrating. Don't be afraid to stop the videos, to go back and rewatch them. If you've got any individual questions, shoot me an email. Guys, I know this is not the ideal way of teaching lessons. This is not what I signed up for, to sit here teaching to a little dot on a screen. I miss the interaction. But you know, in where we're living right now, we're just going to have to deal with this. So let's take a look at another sample problem. Suppose I've got f of x equals 3x minus 4, and g of x equals 1/3 of x plus 4. Two functions here. And what I want to do is I want to find the composition. Find f of g of x. All right, so f of g of x. Which one's going where? I'm going to take this and substitute it in there for x. So start with f of x. I'm going to start with f of x, which is 3x minus 4. And then f of g of x. So now I'm going to substitute g of x in there. 3 times x minus 4. But this is where my g of x is going. 1/3 of x plus 4. 1/3 of x plus 4. Simplify this, distribute the 3, and I get, that's just going to be 1x plus 4 minus 4. Oh gosh, look at that. Everything seemed to cancel except for just the x. I get just x alone by itself. Let's do it the other way around. Let's find g of f of x. So now what's the function I'm going to start with and what function is going to go inside? I'm going to start with g of x, which is 1/3 of x plus 4. And then g of f of x is going to be 1/3 of x, which is that one right there, 3x minus 4, plus 4. So this x became the 3x minus 4. Simplifying, I get 1/3 of 3 minus 4. Oh, they cancel, and I just get 3x, and I just get x again. Now we already saw that this doesn't happen all the time. The first set of examples that I did, f of x and g of x, f of g and g of f were completely different things, and you really can't tell one from the other. But in this case, and as you can guess, I chose these two functions very carefully, that f of g of x and g of f of x both ended up being x's. Both cancel. Well, this is as you can imagine, this is a special relationship between these two functions here. These two functions are inverses of each other because f of g of x is the same thing as g of f of x, which was just x. There's a very special relationship here. These are inverse functions of each other. All right, so the next thing I'd like to do is kind of doing this backwards a little bit. So here I'm going to give you a composition function. I'm going to tell you that f of g of x is the square root of x squared minus 3. And I want you to find the f of x and the g of x that would make this composition true. And there could be more than one correct answer here. The f of x is the outside function, the g of x is the inside function. So if I take a look at this, I could have my outside function as the square root of x, and my inside function is x squared minus 3. Because then as I plug this in there for x, I get the original function. And there could be more than one correct answer here. There could be a couple of different answers here. All right, ladies and gentlemen, that's it for 6.1. So I would like you now to do the assignment from 6.1, which is going to be on page, let's see, where does it start? On page 413. And I want you to do problems numbers 19 through 27, just the odd problems. And then I want you to do 33, 37, and 39. And then you're going to have to email me this assignment. Email me the completed assignment. And I would prefer to get it as a PDF or a JPEG picture. And you can just send that directly to my email. You can either shoot me an email in Canvas, or you can send it directly to robert.shannon@gccaz.edu. And then I will be grading these assignments and putting them in, so the grades will continue from here with these assignments. All right, this is only half the normal night's lesson, and we didn't get a chance to do any questions and answers. I'll certainly do more questions and answers, more sample problems. A lot of times in class, I kind of look to see, well, did people get this? Did they understand that? And kind of monitor and adjust and do extra examples if needed and if necessary. Most of the video lessons here are just going to be all of the basic stuff. And then if you've got questions, shoot me questions, and I can answer them and shoot your answers back. Sometimes I might actually send you a picture back. That means that I've done some work on a piece of paper, I took a picture of it, and I'm sending it back to you to answer. Or if a lot of people answer me the question, if a lot of people say, oh, you know, Rob, I didn't get number 37, then I might just do number 37 and post it as an answer so people can see it. I don't know what's going to happen with the tests in the future. GCC really hasn't decided whether we're going to be getting together back and doing tests or not at this point. I really don't know. I suspect that at some point before the end of the semester we will be getting back together again and maybe being able to do at least the final. But I don't know at this point. So keep up on the emails. I know there's a ton of emails going back and forth right now. It seems like things are changing every few days, are changing. Just kind of be aware of that, and please be safe. If you don't need to go out, don't go out, and be safe. If you got any other questions, shoot me an email. Thanks, guys.